Let us discuss binomial heap union. This function receives two binomial heaps and union these two binomial heaps. See, it is not merging. It will union these two binomial heaps and return a standard binomial heap. Return H. H will be a standard binomial heap. This function binomial heap union, it will do binomial merge. First we have seen this h1 comma h2, these two binomial heaps will be merged and produce a non-standard binomial heap. Non-standard means, see, this one has two b0s, two b1s, etc. In a standard binomial heap, only one b0 is permitted, that is only one b key is permitted, only one. The output of this merge operation is a non-standard binomial heap. We have seen this merging, but this operation simply collect the binomial trees of the same degree and put them together. Then the remaining statements will standardize this or rearrange the nodes of this non-standard binomial heap and create a standard binomial heap that is H, and finally it will return that standard binomial heap. Okay, we will see this operation union through an example. Once again, this binomial heap union function receives two binomial heaps, two standard binomial heaps. Then it will merge these two binomial heaps and will create a non-standard binomial heap. Then the remaining statements of this function binomial heap union will make this non-standard binomial heap a standard binomial heap H and will return H. This is binomial heap union algorithm. It receives two binomial heaps, standard binomial heaps H1 and H2. First it will create a binomial heap object H, then head of H equal to the binomial heap merge H1 and H2. You will be merging two standard binomial heaps. You may get a non-standard binomial heap as we have discussed. Then if head is equal to null, then nothing to do. Otherwise we will create a variable, a pointer variable x and make it null. Then x, it is the head of h. X will be pointing to the first node of this binomial heap, and next x, it is the sibling of x out of the second binomial tree. Okay, so previous x will be pointing null. X is pointing the first node, that is the root of the first binomial tree. Then next x will be pointing to the root node of the second binomial tree. Remember, this binomial heap is a collection of binomial trees. Let us see this. These are H1 and H2, two binomial heaps. After merging, you will be getting a non-standard. Previous x, it is pointing to null. Then this is x and the root of the first binomial tree. Then this is next x. Okay, this is a non-standard binomial heap. Let us go through the algorithm. Okay, after initializing this previous x and next x, we are entering a while loop. While next x not equal to null. While next x not equal to null. Statement 9, that is line number 9, it is true now. Line number 9, it is true, that is the while loop. Then line number 10, line number 10, there is an if statement. Here we are checking degree of x and next x. Okay, these two are not equal. Then or, okay, or means if any of this condition is true, the if statement will work. Okay. Degree of x and next x, that is in this case first binomial tree and the second binomial tree are of not of the same degree. The merge algorithm will arrange B0 first, then B1, then B2, then B3, like that. The degree will be increasing monotonically. First B0s, then B1s, then B2s, like that. Then the degrees are not equal means these two are not B0s, not B1s, not B2s. Okay, then we should accept these two binomial trees. Then we will proceed. Okay, that is next x will be next x, and we have to consider the next one and the adjacent binomial heap. Okay. Binomial tree. If the degrees are not same. Okay, but it is not the case here now. We have to do something because the degrees of these two binomial heaps are same. So line number 10, it is false, or then two conditions there. Sibling of x, next x is not equal to null. Okay, next x, it is not the end of the binomial heap. There is one node after this next x. So sibling is not null. This condition is false, and this is the sibling of next x, and its degree is 1. Okay, degree it is comparing against degree of x. Degree of x is 0. So they are not equal. Okay, so it is false. So after this line number 10, these statements will not work. It will go to L13, the line number 13. Okay, line number 13, the else part. They will be checking the key of x. They will be finding out which is the biggest key, q of x or q of next x. Okay, we have seen the link algorithm. In that algorithm, binomial heap link, in that y comma z will be the parent. That is, the root with smaller key value become the parent. Root with smaller key value becomes the parent. Then coming to L13, key of x is 12 and key of next x is 18. So this condition is correct. Statement in else condition is correct. That is, key of x is less than key of next x. Okay, then we have to do sibling of x equal to sibling of next x. Sibling of x equal to, that is, L14. L14 will work. L14 will do sibling of x equal to sibling of next x. So our tree will be something like our new heap will be 12, then 7, then 3. We are marking the roots only like this. So 18 is out now. Okay, then what do we do with this 18? They are doing 18 is pointed by next x. There is a pointer next x. Okay, then so we will never miss this 18. Then L15, in L15 binomial link the next x, the highest value, that is next x, that is node 18 comma node 12. X is 12. This node will be linked. The output is 12. It will be the parent, that is the key with node with smaller key value. Then 18 will be its child. Okay, that is link. Then so after this, we are getting a heap, or h equal to (12), 18, then 7. We are marking only the root. 3, then 15, then 6. This will be our new heap. We have completed the first iteration. We got a new binomial heap. Here the previous x is still null, x is 12 and next x points to 7. Okay, in this case we are coming to line number 9. While next x not equal to null. While next x not equal to null. Line number 9, it is true. Line number 9 is true. Then we are coming to line number 10. Line number 10. In the degree of x not equal to degree of next x, that is false. Or next condition is sibling of next x. Okay, that is true. Sibling of next x, it is there. Then and degree of sibling of next x. Sibling of next x is node 3. Its degree is 1 and degree of x is 1. Okay, so true and true. So line number 10 gives true. So line number 11 will be working. Line number 11 will be working. Their previous x equal to x. So previous x also points to 12, node 12. Then x equal to next x. X equal to next x. Now the new x will be 7. Okay, the if condition is okay. Line number 11, line number 12 also what? X equal to next x. Okay, line number 12, line number 12. Okay, then line number else part will not work, and line number 21. Line number 21. Next x equal to sibling of x. Next x equal to next x equal to sibling of x. So next x will be 3 now. Okay, line number 21. Then again we are moving to line number 9. While next x not equal to null. While next x not equal to null. Okay, this is true. Then line number 10. Line number 10. Then the first condition is degree of x not equal to degree of next x. Okay, that is false. They are same. They are same. Or then sibling of next x not equal to null. Okay, sibling of next x is there, so it is false. Not equal to null, so it is true. It is not equal to null, it is true. And degree of sibling of next x. Sibling of next x is 15. It is B2. It is B2, and so its degree is 2. Degree of x is 1. True and false. So this is false. Line number 10 is false. So it will be coming to line number else part, line number 13. Line number 13. In line number 13, key will be compared. Key of x is 7 and key of next x, it is 3. So next x is less. Q of x less q of x is 7. 7 less than or equal to 3. This is false. So line number 13 false. Then come to else part. Previous of, that is line number 16. Previous of x equal to null. Previous of x is equal to x is x now. So it is false. Then coming to else part. That is line number 18. Line number 18. Line number 18. Sibling of previous x equal to next x. Sibling of previous x. Sibling of previous x. Previous x is 12. Okay, that is dropping this one 725. Okay, so dropping 725, we will be getting sibling of previous x. Sibling of previous x is equal to next x. So we will be dropping this 725, then establishing this link. Okay, then what do we do with this 725? That is line number 90. That is link link x. X is 7 and next x is node 7 and next x is node 3. So we are getting 3, 37, then 7, 25. So after this iteration, this is the change. So our new tree will be our new heap, binomial heap, will be head of h 12, 18, then 3, 37, 7, 25, 3, then 15, then 6. 15 is AB2 and 6 is AB4. 6 is a root of B4. 15 is a root of B2. Okay, and next x is 3 now. Okay, x is 7. Okay, then so link. So after line number 19, we have done the link. Then x become, that is line number 20. Line number 20, x is equal to next x. Now x is, okay, x equal to next x. So this will be x now. This will be x, and line number 21. Next x equal to sibling of x. Next x equal to sibling of x. So this will be the next x. Okay. Again, line number 9. While next x not equal to null. While next x not equal to null. L9, it is true. Next x not equal to null. Next x, okay, next x is there. Next x not equal to null. It is there. Then line number 10. Line number 10, we are inside the while loop. If degree of x not equal to degree of next x, degree of x is 2 not equal to degree of next x is b 15 is a b2, so degree are same, so not equal to, this is false. Or then we are checking sibling of next x. Okay, sibling of next x is there, not equal to null, it is true. And sibling of next x, it is a b4, is degree of x is 2, that is false. So line number 10 is false. Line number 10 is false. So else part will work. We are here on line number 13. Line number 13. Q of x and Q of next x. Q of x and Q of next x will be compared. Q of x is 3 less than Q of next x is 15. Okay, this is true. This is true. So line number 14. Sibling of x equal to sibling of next x. Sibling of x. So this will be bypassing. Okay, like this. Then that is done by L14. Then L15, that is link, binomial link. Next x comma L15. Okay, next x, that is 15 comma node 3. So 15 will be the child of node 3. Line 15. Okay. We will get new binomial heap. Three. Okay, already we have 37, then 7, 25, then 15, then 33, 15 as 28 and 14, then 16 a b4. Okay, then after this line number 15, line number 21, line number 21, line number 21 will make next x equal to sibling of x. Next x equal to sibling of x. X is here, this 3. Now next x equal to sibling of x, so this will be next x. All this done by line number 21. Okay, again we are on line number 9. Line number 9, line number 9, next x not equal to null. Okay, this is true. Next x is not equal to null, and we are on line number 10. Line number 10, degree of x not equal to degree of next x. Degree of x is 3. Degree of x is 3, not equal to. Okay, this is correct, so true, or whatever it is, it will work. Line number 10 is true. Degree of x not equal to, degree of x is 3, not equal to degree of next x. Next x is b4. Next is b4. Rotated 16, so their degree are not equal. Okay, so we will succeed line number 10. Then line number 11. Line number 11, previous of x equal to x. So previous of x, previous of x equal to x, then x equal to next x. X equal to next x. X equal to next x. Okay, then line number 21. Then line 21. Next x equal to sibling of x. Okay, next x equal to sibling of x. It is null. This is new value of next x. Then again we are on line number L9. It is false. Then we are on line number 22. It is returned H. H is the standard heap. This is a B1, this is B3, and this is B4. We got a standard heap.